Hi, Yorick here. Today I'm diving into a rabbit hole. We're discussing mirroring and storage redundancy on the Staker Discord, and that got to ZFS on Ubuntu. And so there are instructions on how to do this mirrored, and they're a little bit involved. So what I figured out was how do I install an Ubuntu Desktop with ZFS, which is a single drive, and then mirror it after the fact. It's a few steps which I'll go through here on command line. I'll assume you already know why you want ZFS and what all it gets you. If not, take a quick look at Ars Technica, Introduction to ZFS, and maybe take a look at the why here, that I have on the screen and will also link. Okay, let's dive right into it and just get to how. So all drives that I'm using here will be formatted. This is only for bare metal install on drives. You can't use this for dual boot. No hardware or software RAID from the system itself, as in the BIOS. This is just AHCI, and ZFS will handle the mirroring. And then I'm doing this with UEFI and GPT because that's been around for 10 years, and I'm not bothered about BIOS and MBR anymore. If you are and your system is that old, then full instructions will be linked to how to do this manually. All right, so assuming you have an initial Ubuntu install, where you chose ZFS, when you do a zpool status, you will see your pools. There's a pools. Pools. Yeah, there's a B pool and an R pool. Boot pool and root pool, and we can see where these are mapped here with a DFH. So you see B pool is just the Ubuntu UID, and it's mapped to boot. Boot EFI is actually directly on the drive, def SDA1, and it will stay there. And then our pool is the root, and we got a bunch of different things that are gotten into varlog, varlib, var3w, and so on and so on and so on. Right? This is actually quite useful to have this in different data sets. If you are so inclined, you can have snapshots for individual things. Okay, so I have a second drive in this system, and I am going to add that as a mirror to the B pool, the R pool. I'm going to have swap mirrored, and then I need EFI on both drives so that if one drive is physically gone, I can still boot from the other. First, I need some updates to Ubuntu, which actually I already did, but I'm just going to show you what this looks like. Aha, there's a couple things that want to come in. And then I need the names of my two disks. I'm going to do this by ID. So it's the dev disks by ID that I'm going to be looking at. And you can see here this drive, SCSI 3.5 and so on, that is SDA, and I have my Ubuntu partitions. This is what I chose when I installed, and the other one is SDB. This is free. So that's going to be my mirror drive. I am using SAS hard drives for this just because I have them and they're cheap. In production, if this was something that needed a little bit of performance, like an Ethereum 2 node, then these would be SSDs, either SATA SSDs, NVMe SSDs, doesn't really matter, right? So first I'm going to set some variables here so that it is easier to refer to these drives going forward. So the first one is going to be my drive 1, this one right here, copy, paste, and then we're going to do disk 2. I need a couple tools which I will now install. gdisk, version of grub, mdadm. So let's first take a look at the partitions on the first disk, the one that Ubuntu is installed on. And I have my EFI partition. That's the swap partition here. That's my boot pool, and then my actual root pool. I'm going to change the swap partition type because that's not going to be swapped directly anymore. that's actually going to become part of a mirror that swap will be installed on. And then what I want to do is I want to take this partition table and move it over to disk 2. So you see here dash uppercase R, no space, disk 2, and then from disk 1. And now what I need to do is I need to change the unique IDs on disk 2 so they're not the same as on disk 1 anymore. And if I want to, I can now take a quick look at that, at those partitions on my second drive. And here they are, right? Now I'm going to mirror the boot pool. So again, I have two pools, B pool and R pool. So first I need the UID of that partition on disk 1. And I'm going to paste that in here with a zpool status. Now I already know that this partition unique ID here, this one, will match the device in B pool. This step is just to verify that. If that's not the case, stop, something's not as expected, you need to adjust the instructions. Now I need the unique ID on the second drive for partition 3. So it's that one right here, 5, 4, and so on. And now I'm going to just attach it to this device here. So ZFS allows me to take a single device, attach a second one to it, and end up with a mirror. And that's what I'm going to do. So on the boot pool, I'm going to take the existing UID here, and then I need to get the partition unique UID. I'm going to move my camera so I can see what's going on. And this will be starting with, here it is, 5, 4, and so on. Now this is case sensitive, so I can't just copy paste this. Instead, I'm going to go 5, 4, and then tab, and hope for the best. That didn't do it. A8. All right. I'm missing a. Here we go. Help if I have that. There we go. All right. zpool attach is part of an active pool. Ah, yes. I was using this this drive before for testing. That's why this is happening. I probably should have wiped it instead of just clearing its partition table. Okay, so now if I do another zpool status, you can see I have a mirror here, and it told me it resilvered this in 7 seconds, right? Great. Now I need to do the same for the R pool. One more time, the reason this attach command gave me an error is that I had used that second drive while I was writing the instructions. So when I put the partition table back on, it found that this had been used previously for a pool. Okay, so now I'm going to take a look at partition 4 on drive 1, and again at the status of my zpool. And you can see here I have my DD98 and so on, and that is the R pool, the root pool. That's the name of the pool. So that's good, that matches. And then I need the unique UID of partition 4 on the second drive. Starts with 4EC. And I'm going to attach this again, this time because I know it's going to give me an error. I'm just going to do the -F or right away, right? So I need this guy here. Not attaching to this one. I could, but I don't want to. I don't want a 3-way mirror. I want a 2-way mirror on this pool right here. And then it's going to be def disk by partition UUID, this time with the slash in the front, and I have 4 EC and so on, and then -F. Gonna take a minute here, and when it is done, I'm gonna run another zpool status. Okay, wonderful. So this now says resilver in progress, because these are spinning Rust and it's gonna take a minute. No problem, I can just let that run. And I have a mirror, right? My boot pool and my root pool are both mirrored, so I can lose drives here. However, my swap isn't mirrored and my EFI isn't, so let's fix that. So first I'm going to mirror the swap, and what I'm going to do is I'm going to unmount the current swap drive, which is just on SDA. And then I need to go into fstab, this guy right here, and you see this line here that says UID equals for swap. This needs to go. I need to get rid of this. Just going to delete that, and then Control X, save modified buffer. Okay. Now I'm going to create a mirror on the second partition using mdadm. So I'm creating dev md0 with a mirror to devices, disk 1 partition 2 and disk 2 partition 2. Yes, now I can continue creating array. Yes. Alright. Okay. Now I'm going to create swap on this device. Alright. And put that swap into etc fstab. And I'm just going to cat that right quick to see that that looks right. So now I have my UUID here. I could delete this empty line if I liked. And I am going to tell the system to start using it with swap on. And then I'm going to just test that it's actually there with a -S. And I see def md0, and that's my 2 gig of swap space. Great. So that's swap done, and I'm going to move my grub boot menu to ZFS, which is currently not there. So first to test that boot, which is ZFS drives, can be seen by grub, so that's working. And then I'm going to create a file system on the second drive, partition 1, and remove grub from fstab. So see this line here, boot EFI grub, that is gone. I'm going to get rid of that. And then just save that again. And unmount boot grub. And then just do a quick DFH and verify this. So what I expect to see now is rpool boot Ubuntu UID, this guy right here, should be on /boot. So that's good. Boot EFI should be on dev SDA1, that's, or whatever your first disk is, right? That's working. And I am expecting to not see a boot grub, and I do not. So that's good. And I'm going to remove the boot grub directory and then create a dataset for it, a ZFS dataset. And then just update the init RAM FS. I'll take a small minute here. While that's going, next thing I'm going to do is I'm going to change a setting in the boot command line for Linux. Turn off init on alloc. That has to do with ZFS performance regression. If that's set to 1, which is the default, ZFS can get quite slow on Linux. So I'll want to change that so it doesn't do that and it stays performant. Alright, so this one here, grub command line Linux default. I want to add to this init on alloc equals 0. Just like that, and then save it again. Update grub so it knows about this change. I will probably see errors from OS Prober, which I can ignore. Yeah, these ones right here, yeah? OS Prober, Linux, SDA4, SDB4, that's fine. And install grub to the ESP. Once that's done, last thing I need to do is disable the failback service. There's a bug upstream in Debian Ubuntu that keeps this from working. So the failback service or fallback service, unfortunately, is no longer available. All right, I shall reboot. When I'm rebooted, I just need to install grub to the second disk, and then I should be done. So sudo reboot. See you in a minute. My Ubuntu survived all this stuff. So my zpool status is still good, and my swap on S shows me that def md0, the mirror, is now the swap. Need to do that with sudo, and this one is doing well as well. Now I just need to install grub to the second disk. So I'm gonna reconfigure grub EFI AMD64. I'm not going to make any changes to the command line, not any changes to the default command line. NVRAM to automatically boot, keep that at default. The only thing I'm going to do here is check this second def SDB1 and then hit tab and hit OK. OK. And when that's done, for good measure, I'm going to tell it to reconfigure signed. Not sure that's necessary, but it can't hurt me. So the last thing I'm going to do in this video is fail a drive and show you that I can still boot in. What I don't have is how to replace a failed drive. I'll need to write that up. It's going to be somewhat similar with creating the partitions, but some of the stuff I just did, like swap and so on, that's already done. So I just need to, the MD0 is now here, I just need to replace the failed drive in that rather than creating the RAID from scratch. Okay, so let's pull a drive unceremoniously, the boot drive. Here it is. Now when I do a quick zpool status, hasn't noticed this for the bpool. My this is very, very unassuming hardware, so it doesn't necessarily know I just pulled this, but I did see it on the root pool, and mdadm probably noticed. Let's take a quick look. Again, super user. And yes, I knows I removed this. So one more time, I'm going to reboot, and I'm back in on just one drive. Let's just take a quick look at what zpool thinks. So my boot pool is degraded because there's a device missing here. My root pool is degraded because there's a device missing, and the swap def md0 should also show me that I'm missing a device. So this is clean and degraded, and this guy has been removed. So now I'm just going to put this drive back in, allow it to spin up, and see whether I can bring it back in. So so far, that's really all that this video I wanted to show, how to, after the fact, add a second drive to an Ubuntu ZFS installation. If you don't want to go through the 100% custom, this is kind of like 40% custom or whatever percentage, right? So just a standard box, standard ZFS install on a single drive, and then add in RAID for the swap and a mirror for the pool after the fact. Now, if all that happened was that the drive is okay, but it just got disconnected, I can bring it back in. Replacing a failed drive, I still need to write that up, and then I'm going to have a separate video on that idea. So dev disk by ID, I can see that my second drive is back here. I can see it. It exists. Or I could do this with a -L. This is my SDD is what it's calling now. This is actually, I'll stick on this for just a second. So because I now put this in after the fact, this is no longer STB, this is now SDD. This is the reason that I did everything with unique IDs and dev disk by ID, etc. Because these drive letters, if you want to think of them that way, SDA, SDB, SDD, those can change. If things move around in my system or I move to a different system, those will change. But the ID will remain the same and the UID will remain the same. Okay. Or more specifically, the UID will remain the same. And that's what I used in zpool. Right here, these are all partition UIDs. So what I can now do is I can tell zpool to online this device, and we'll see whether that works. So I say in the boot pool, I want you to online this device that appears to be unavailable. Okay, with a sudo would be nice. Alright, now when I do a quick zpool status, I can see that my mirror is fine again. I resilvered a little bit of data. That's just what was driven on the written on the boot pool since I took the drive out. I'm going to do the same for the root pool. So sudo zpool online root pool, and then this device here that's missing. And that's looking good as well. So it's going to take a minute here, and I'm going to do a zpool status again. And you can see it resilvered 70 meg, which is what was changed on the root pool. All right, that's all. As I said, I'm going to have another video on how to replace an entirely failed drive. But until then, thank you. I hope this was, as always, useful.